This video will cover what is known in the function list as the Trend Edge Stain tool. This is a useful tool that can be used to obtain a profile of the edge of a target by detecting multiple edge points and calculating the best fit shape. This could be a line, circle, oval, or a free-form shape, which is called a free curve. It will compare the actual detected edge points to this reference shape and detect any points that deviate too far from the ideal shape. It is great for detecting flaws along the profile of a target like dents, short shot, or flash. The Trend Edge Stain tool is also found within the Stain Flaw tool category. It's the same tool, it's just optimized for a certain shape. Flaw on line will detect the best fit line and use that as the reference model. Flaw on ring will use a best fit circle or oval as the reference model. And flaw on curve will detect the best fit freeform curve as the reference model. I'll show you an example of each of these. For our first example, we'll show the flaw on a line tool, which will create the best fit line. The first step with all tool setups is to store a reference image or register the image if you haven't done so already. We've already stored the image, so you can see the reference image is being displayed right now. It's a reference image that we can use to set up our tool with. Next, we will set up our inspection region. This is the area on the image that you want to scan for the profile of the edge and perform your inspection. In this example, we're going to profile the edge of this solar cell and look for any flaws along this line of this edge here. So when you choose flaw on line, the only choice for inspection region is rectangle or rotated rectangle. So we'll just go ahead and use rectangle, and we'll set up our rectangle along the profile of this edge. Once you have the region set, just click OK. The next step then is to set up the edge detection conditions. In other words, the conditions for which to scan your profile your target for the edges. One of the main settings here is the trend direction. So this is the direction for which to break up the region into many small segments and find the edge points. So it can be set from top to bottom or left to right in this example for rectangle. It's already set for what we need, top to bottom. So what it'll do is it'll start at the top, perform an edge scan and find an edge point, shift by a certain amount, perform another edge point, and so on. So it'll start at the top, work its way all the way down, and find many different edge position points here. Those are the points in yellow, as you can see. The scan direction is the direction of the edge detection, and it's always perpendicular to the trend direction. You can set up all the rest of the edge detection conditions as needed according to the application. You can also adjust the segment conditions as necessary according to the application. So like segment size, segment shift, and max number of segments. So basically in our example here, what we have is a segment size of 5. So it's a 5 pixel wide box. This individual segment, it'll scan and look for an edge. Then it'll shift by 3 pixels, and do it again. Shift by 3, do it again, and so on from top to bottom. So each one of those yellow points again is a detected edge point. And our max number of segments is set for 200, so it would stop at 200. You can, again, adjust those according to the application. If you click this numeric icon up top here, you can actually take a look and view the number of segments you have. So segments is 135. That's how many total segments we have across our region. And detection segments is how many of those segments have actually detected an edge. So you can see all 135 of them have detected a valid edge point. In general, the smaller the segment size, the more sensitive it is to pick up on smaller defects. Now that we have our edge detection conditions all set and we're profiling the edge of our part correctly, we can move on to the stain detection conditions. One of the settings is the reference model or reference shape. When you choose the flaw on line tool from the stain flaw category, it's already fixed at line, so there's no need to change that. So what's going to happen here is after it detects all those edge points, as you can see here, those are the points in yellow, it will calculate the best fit line from those points, and that's the line you see indicated here in green. The stain scan direction is the direction for which to look for the flaws or defects. Once it calculates that best fit line, it's going to compare the actual edge detection points to the best fit line. It's going to determine if the point is above or below the line. So as a default, it'll look for flaws or defects above or below the line, but you can dictate that direction. So to show you an example of this, let me trigger on an image here that has a flaw in each direction, as you can see here. So we got a flaw that falls to the right of the line and the left of the line in this case. So it's detecting both by the little crosshair you can see, but if you change that direction, we can look for only flaws to the, in this case, right of the line, or we can set it for minus, which will be left of the line here, and it's indicated there with the arrow. So again, the default is both directions, but you can dictate that direction as needed according to the application. One other setting here is plus or minus each. The difference here is you can set a different detection threshold for each direction if you'd like, depending on the application, which is what I'll talk about next. But for our example, we're just going to leave it on the default. The detection threshold defines the distance in pixels from the reference line for which it detects a flaw. In other words, how far can the actual edge detection point be from the reference model line before it becomes a detected target, if you will. So again, I'll use this same image in this example to give you an indication of this. Let me just zoom out a little bit. So you can see this. You can also get an indication from this graph of the size of the flaw here. So what's going on here is it's detecting all these edge points. As you can see here, the green is the best fit line, and it's measuring the distance of each one of these edge points, how far it is away from this model shape. And this graph kind of gives you an indication here. This green down the middle is the reference model line. These are the actual detected points, and this line here in orange at this moment is our detection threshold. So you can see those points passed that threshold and they became detected points. And you can adjust that threshold as needed according to the application. But it looks like the default level of 3 is okay for us. If we go into the detailed stain detection conditions, there's actually a filter that we can set on some of these parameters here. So if you'll notice here, there's lower stain level, width, filter, and size. So let me explain what each one of these are. So stain level, let's start there. So what I'll do is I'll click this numeric icon so you can see what's going on. First here you can see that we've detected 2 flaws in this target here. So we got 2 detections right now. So that's the stain count. By the way, that's detection count here. This is a max number, so it's set for 50, as you can see right here as a default. So it'll count and detect up to 50 flaws, and you can adjust that as needed. But we'll leave it at 50. The total size and total level I'll get to in a minute here, but if I click to the right, you can see the judge label, which as a default is the biggest detected flaw. In this case, it's the one indicated here in green. You can see it's got a size of 58.891, a level of 9, and a width of 8. So what these settings are, or what they mean, is let's start with stain width 8. So if I zoom in on this a little closer here, you can see there's 8 segments have passed our threshold that we set, the detect threshold of 3. And those are the points you can see in this primary or judge label indicated here in green. So it's the width of the stain. So how many consecutive segments failed or passed that threshold. The stain level is the max peak point. In other words, this point, if I zoom way on this, you can kind of see it's got a little black circle around it, but it's the peak point, the furthest away point for this detected flaw. So 9 pixels away in this example. So it's 9 pixels from the ideal shape. So in other words, it knows the distance of each one of these points, and it tells you the peak point. Now the stain size is basically all the levels added together. So it's how far this point away is, added to how far up away this point is, etc. All the points added together. So it kind of gives you a kind of like an area under the curve, if you will, so a kind of a size of the target. So that's the size, level, and width. So I zoom back out here. So once you have those set, you can filter off unwanted conditions if you want. So for example, this flaw here, if you want to see what this is, if I scroll again to the right, you can actually see the individual size of each one of these detections. So you can see the second one here has a stain level of 4 and a width of 4. So what I can do is, if I wanted to filter out that one, if that's not a desired detection, I could actually put a lower stain width filter or level filter or any one of these filters here. So let's say level. If I set the lower stain filter level to 5 or 4, anything 4 and lower will be ignored, so you can see it's ignoring the detection there. So these lower level filters can be used to filter out unwanted detections. Under detection options down here, this is how once these flaws are detected, how do you want them numbered, the detection order. So as a default, it's just size descending, but you can change that as needed. And here's that judge label. Again, it depends on your detection order, but whatever's first in the list, that's your judge label. You could also set this to all if you want to put limits on all the targets when you set up your judgment conditions. So let me fit this back to screen here. And if I scroll back to the left here to show you the total size and total level and total width again. So the total size is all the sizes added together. So it will add the size of each detected target together and give you a total size. The total level will literally add up the total level, so the level of each one. So the peak point of each one will be added together to kind of give you a total level. And the total width is all the widths added together. So in other words, how many total segments actually failed the detection, the threshold. So that's it. And then the next step will be to set up your judgment conditions here. The judgment conditions are the pass-fail criteria for the tool, which will make it be okay and no good. Probably the easiest way to set this up when using the trend edge staining tool is just to simply put a limit on the count, an upper limit. So if we don't want any flaws, we want it to fail if there's any flaws, just simply put an upper limit of 0. So any detected flaw will fail the tool. So if I trigger on a part here, you see here's the good part. So anytime a detection occurs, it would fail it, but you could set that accordingly. Also, you could set a limit on the total size if you'd like. And if you click the details here, you can set other conditions like count, we already set, the total size again, and then the stain size, which is, again, a limit on the individual sizes of each detection. So if I trigger on one of these parts here, you can see it gives a min and max. Now, if you recall, back over here on the detection conditions, when we set this to all, that's what changed what's coming on over here. So you can see when we scroll down, we have a min and max size and a min and max position. But if we left that setting over here to specified, I'm going to go back to the limits, it'll be just that one specified target. So you could only set a limit on just that main judge label. So again, if we put that back to all over here in detection conditions, it will allow us to put a min and max limit on the stain size and position if you like. In our example, we're just going to simply leave the count upper limit to 0. So if I click OK, we can again run the tool, and you can see anytime there's a none of the points along that profile fail, we get an OK. If we get any detections at all, the part will fail. So we're looking for that best fit line, and if any points stray too far from that, we want to know that and fail the part. Now, we're in raw 2 view here. If you switch it over to filtered, you can actually view each detected point if you want to. So if you want to see that view while you're running the tool, you can also switch back and forth between that. Also, while the tool is running, you can confirm all the measured values for the different parameters here. You can see if the measured value passes the criteria that you set, the upper and lower limit, it'll turn green. If it fails the criteria, it will turn red and give you that indication. So anything that you put limits on, if it goes outside that range, it will turn red and fail the tool. In our next example, we'll show you a flaw on ring, which is the same tool, trend edge stain, but it's optimized for a circle or oval. So again, the first step with any tool setup will be to register the image, but we have already done that. We got our reference image being displayed here. So what we're going to do in this example here, we got a basic kind of shape here with a circle in the middle and an oval. It's like it could be a washer or any type of part like that. And what we'll do is we'll look for flaws on the inner part, which is a circle, and then the outer part, which is an oval. Now when you choose the flaw on ring tool, it's optimized for circle or oval, so the only choice for inspection region will be ring or arc. So we'll set up our region now, and again, that's the region of interest where you want to scan. So let's start with the circle and the inner part here. So let me just adjust my inner and outer ring. So what you want to do is set up your inner and outer ring so it'll scan and find the edge points in between these two rings. So kind of like so. So what we'll do is we'll scan and find those edge points. So the rest of the setup of this tool is almost exactly the same as the first example that I showed you. The only difference is, in this case, it's a ring, or it could be an arc, but the trend direction is automatically going to be clockwise, so it's going to break the region up into many small segments, but in a clockwise manner, going starting clockwise. So what I'll do is I'll scan for an edge, shift, 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 find edges all the way around the circle. The scan direction for the edges is centered out or out to center. Again, since it's a ring, that's what you do. So you can adjust all the other edge detection conditions as necessary, and also you can adjust the segment size, segment shift, and max segments as needed as well. Again, the only difference here is the size and shift is in degrees. So when you're using a ring or arc, instead of being pixels, it's in degrees. So we got a 5-degree slice of pie, if you will, and then it shifts by 3 degrees, does another edge point, and so on, going clockwise all the way around the circle. So just like before, you can click this numeric icon and confirm the number of segments and detection segments. After you have all your edge detection conditions set up, as you can see here, we're profiling the circle here. We've got all again, the yellow detected points here are the edge detection points, and then that green circle is the best fit circle. So you then set up the stain detection conditions just like in the first example, except in this case, it's set for circle as a default, which is what we want, or you can change it to oval. So in the flaw on ring case, you can choose circle or oval as the reference model. But all the rest of the settings are the same as far as stain scan direction and the detection threshold. And you can change all that stuff and also use those filters just like the first example. Same exact settings. So we're just going to go ahead and leave them default. And again, same as before, you set your judgment condition. So if I play through some parts here, or if I trigger a part, you can see we have some detected flaws. Again, you can confirm the count, the total size level, the size of the individual flaws, just like before. So we'll go ahead and set the same limit. So an upper limit of 0 for our count, which will fail the tool. And that's it. Again, you can set all the other limits as needed as well as detected segments. Again, what detected segments is how many segments actually detected at edge points. So you can also set a limit on that as well. But again, we're just going to do one on the count. And that's it. So we'll go ahead and click OK, and we'll confirm the part. You can see here, it's a pretty simple example here, but if the part passes, the value measured is in green. If it falls outside our range, it'll turn red and fail the tool. So any parameter or measured value that falls outside any limits that you set will turn red and fail the tool. So now we'll use the same flaw on ring tool to find flaws around that oval. So again, I'm going to choose flaw on ring just like before. And you can see the ring is, again, you set up the ring to where you want the profile for edges, and actually it's pretty much where I need it. So what we're going to do is this time we're going to scan and look for the outer edge. So I want the inner and outer ring set up accordingly. So we'll profile, same as before, and find the outer edge there. So let me go ahead and center this, kind of like that. Click OK. So you can see it's already detecting the points here around the oval. So we don't need to adjust anything, but again, you can adjust all these settings as necessary. Now the one thing we do have to change is the reference line, reference model. It's set for circle as a default, but if I change this to oval, it will switch over and detect the best fit oval, as you can see here. So now it's doing its thing. So again, the setup is identical. I'll go ahead and put an upper limit of 0 for the stain count and show you when we detect a flaw, you can see they are found and the part fails. So again, the setup's identical. Just this example was an oval. So if I click OK, again, same as before. It's failing if it finds any targets. If you're using multiple tools and you want to see them both at once, what I can do is click this multiple region icon here, and you can actually watch both tools do their thing at the same time. So for our third example, we'll show you the flaw on a curve tool, which is going to be, again, the same exact setup, except this time it's going to be a freeform shape that we'll set up as the model line. So I'll go ahead and add the flaw on line tool, and we'll go ahead and set up. Again, we already have our reference image stored, so you can see it's displayed here, and we'll set up our region. Now, you have the choice of rectangle, rotated rectangle, ring, or arc in this case if you choose flaw on curve, because it could be a variety of shapes. So I have a pretty basic image here that we'll use to illustrate this tool. It's kind of a again, a freeform shape. It's not a circle, it's not an oval, and it's certainly not a line. So what we'll do is we'll, again, set up our inspection region to profile the edge of this surface. So we'll put the rectangle around the screen here. So we'll profile the edge of this surface, just like the other tools. If I click OK, you can see it's kind of wacky here, but we need to set our trend direction. So again, this is the same exact setup. What we'll do is we'll set our trend direction left to right, so it'll slice the region up left to right and find all those edge points, as you can see here. You can see it kind of stopped there, so that's probably because our max detected points is stopping at 200. If I change that, that'll complete that. So same as the previous two examples, you'll set up your edge detection conditions and segment size and shift as needed according to the application. So under the stain detection conditions here, everything here is the same as the previous examples like I showed you, the scan direction, detect threshold. You can even use all those filters, same exact settings as before. The only difference is the reference model line, or reference shape if you will, is a free curve line. It's fixed at that when you choose flaw on curve. So the only difference is this smoothing range settings. This is only available when you choose free curve. And what it is, it's literally the smoothing range percentage of the shape. So as it calculates that best fit shape, it's basically how quickly you want it to adapt to changes. So the lower you make this number, so if I lower it down to 5, for example, you can see it adapts quicker to changes. So if I go even further down, lowest setting is 1, but you can see it adapts to these flaws, which is not really what we want. But so this would only detect sharper changes. But you can see 15 seems ideal. The higher you go, the slower it adapts to the shape, if you will. So you can see if I make it high, it's adapting much slower to the shape. So 15 seems to be a pretty ideal level, but you can adjust that according to the target. So I'm going to leave it at 15. If I show you, here's the good target, and here's the target with some flaws. So again, smoothing range is really the only difference from the previous two examples, and you set everything else up the same way, including the judgment conditions. So just like before, I'm just going to set 0 as my upper limit for the stain count, and you can see I can pass and fail according to the target. And just like before, you can view the measured values, and the raw 2 versus filtered screen is the same. All three examples you've just seen were examples of the trend edge stain tool from the function list. The only difference with choosing it from the stain flaw category is they are fixed at that model shape and the region, whereas when you choose it from the function list, you have free reign over first of all, the inspection region. So you choose that from the beginning depending on the application, and then you can, depending on what region you select, you just set your reference line, so it's not fixed. So that's really the only difference. You set up everything else the same. In summary, the Trend Edge Stain tool is a great tool for profiling the edge of a target, calculating the best fit shape, be it a line, circle, oval, or free curve, and detecting any flaws that stray too far from that best fit line. In this example, you can see we're profiling the edge of a plastic cap and looking for any short shot and flash.